seem quite daunting, but it doesn't have to be that complicated. And today we're going to look at really simplifying the process for you in determining whether you need to dredge or not. So we're going to work through our agenda here. First, we're going to talk about understanding your lagoon and really watching for the signs of overaccumulation. Next, we're going to talk about key factors in deciding to dredge or desludge. Then we're going to look at regular inspections and sludge surveys. And then we're going to really get into the meat of it and talk about dredging, desludging, and disposal. And then finally, we're going to finish up with a big sticking point, which is costs. And then we're going to look at the overall decision-making process that you can really utilize to get yourself through the whole process. All right, understanding your lagoon. So lagoons are really designed to remove contaminants such as things like harmful metals, E. coli, salmonella, solids, pathogens, other types of pathogens. Ultimately, effluent discharge from that lagoon should be suitable to be discharged to receiving water body. So lagoons they're very efficient at treating wastewater, and they're still the most cost-effective way to treat wastewater, but they do still require periodic maintenance. That includes grass cutting, weed removal, and of course, the reason we're here to talk today, which is dredging and desludging. The biggest challenge is that every lagoon is different, and we know that ultimately the effectiveness of a lagoon is really dependent on design, climate, wastewater composition, and management practices. So the first of these three items are ultimately out of your control when it comes to dealing with a lagoon that's been in operation for several years. Again, I want to say, unfortunately, we can't change the design easily. We can't change the climate in our region. It's out of our control. And we really can't change incoming wastewater composition. But we can, however, implement good management practices like regular maintenance, such as I mentioned, grass cutting, weed removal, algae skimming and removal, sludge removal. We can do periodic inspections, sludge surveys. We can stay on top of things like repairs, make sure really everything is in order and operating properly. And with these good management practices, we can improve the lagoon's overall health. And today we're really going to focus on determining whether you need to dredge your lagoon, and we're gonna start by looking at something here that I like to call signs of overaccumulation. So we know that too much sludge reduces the hydraulic retention time, or the HRT. And hydraulic retention time is the time that the effluent spends in each cell for treatment. As we get an increase in the sludge blanket, we see a decrease in HRT, which effectively reduces the cell's ability to treat incoming wastewater. Another problem here that we see with overaccumulation is that solids and contaminants end up short-circuiting through cells that have a lot of sludge, and they move into downstream cells. And this is actually a really big problem, and I'm just going to point your attention to this sludge blanket thickness map that I've got here. So we can see there's 4 square cells here. These are anaerobic cells in this system, and then there is a facultative cell that is downstream. Now we can see that in this green area here, this is a region of sludge buildup accumulating, and this is quite a large region. And so what's happened in this location is that sludge from these 2 cells have short-circuited, and rather than settling out in these 2 cells downstream, they've made their way into this facultative cell here. Now, it is possible that these 2 cells were desludged in recent memory, but unfortunately, what's happening is that we're getting a big amount of short-circuiting here. And so now, rather than having these 2 cells dealt with, we now have 5 cells to deal with in terms of desludging. So when we're looking for other signs of Overaccumulation, we want to look for bad odors, floating solids that could be synthetic or organic. We want to look for things like algae or duckweed. That can be a green mat that's floating on the surface of the lagoon. We're also going to be looking for things that you can't visibly see typically at a lagoon, like declining effluent quality. And declining effluent quality is something that you would have to measure over time and notice in the results of your sludge sampling. And then also one thing we can spot too are visible islands or sludge beaches. Those are pretty easy to spot and are big signs of overaccumulation. And then other things are infrastructure issues. So if you're having inlet backups, broken aeration, broken mixers, those are signs of overaccumulation. And now you may not be able to pinpoint exactly that these are caused by an overaccumulation of sludge. But as we move forward here, you're going to see how we can decide whether sludge is the culprit. All right, we've got some key factors here in decision making. So how do we know that we need to dredge or desludge? Well, we have 5 pretty important factors to show us whether we're going to need to desludge. Now, it doesn't mean we have to have all of these factors. It could just be one of these factors that you have that require you to desludge. So the first is sludge accumulation. Like we discussed previously, too much sludge accumulation can really compound problems at the lagoon. And so if you've got too much sludge, the only solution here is to dredge or desludge, get rid of it. The second key factor here is treatment performance. If you're noticing a steady decline in your effluent quality, then you're going to need to take action before we get to the third key factor here, which is regulatory compliance. It's really, these two points 2 and 3 are really tied together. You may be failing your regulated limits, and if that's the case, you're going to need to take action quickly. If you're not failing your regulatory limits, but you are seeing a decline in your effluent quality, you could be on your way to failing your limits, and so you really don't want to get there. And so in order to deal with these, dredging and desludging may be your only solution. Then the fourth key factor we have here are operational challenges. This actually encompasses a huge range of issues, but we've seen things in our time of doing sludge surveys. We've seen things like inlets backing up because they're buried in sludge. We see frequently aeration systems being broken and in disrepair. And so even with those simple operational challenges, the only solution in those cases is to really get out there and dredge or desludge in the problem areas to really solve those operational challenges. You certainly don't want your lagoon inlet to be backing up and forcing sludge to be accumulating in your collection system. That's pretty bad. Also with aeration, that's a very expensive treatment system that if it's not operating properly, you're just spending a lot of money on blowers running to not get the treatment that you're intended to get. And then finally, the last factor here are hydraulic capacity and storage volume. This is pretty important as well, because if you're managing a municipality where you do have a lot of incoming flow and you rely on your cells to store a lot of volume for an extended period before you can discharge, then you will really need to know how much capacity you have and how much storage volume you have. If you already see that your water levels are high in your system, you could be at risk of overtopping, and then other things can trickle down from that. If you did have an overflow, you can risk damaging the berms or other infrastructure. So really, not only will you be releasing contaminants to the environment in that case, you can risk damaging that other infrastructure. All right, we're going to chat quickly here about simple periodic walkdowns. Operators should really be walking the entire site at the lagoon or wastewater pond. They should be looking at the infrastructure They should be taking photos, making notes of unusual observations. They should really be building themselves a knowledge base of what's going on at that lagoon. We see a lot of turnover with folks retiring and new operators coming in. They really don't have great history, and so they need to build that up for themselves so they know how to start solving the problems. These walkdowns are perfect time to look for signs of it over accumulation. We spoke about this, about these items in the past slide, but I'm just going to reiterate: bad odors, floating solids, visible islands, or sludge beaches. Another thing they can do is just look at clarity and color of each cell. So does one cell look red and the others look normal? Does one cell or a few cells appear very clear? One is very dark green in color. These changes in colors can help you really identify whether one particular cell may be having a problem versus the other ones. It can also spur you into action, whether that's doing a sludge survey or investigating, maybe having a look at the last set of samples you collected to see if there's any noticeable changes in your effluent criteria. And then again, you might often identify another issue when you're walking around. You might identify something like really bad erosion in an area at a far corner of the lagoon that you just have never noticed. Some larger ponds can get some really big wave action, especially here in the prairies. We see sometimes big waves pick up when there's a lot of wind. So you don't know, you could have bad erosion or sloughing. So walking the entire site is a really good idea. You can certainly spot other things as well. Then you want to move forward by starting with a sludge baseline. So when you conduct a comprehensive sludge survey, you're going to get the data you need to make informed decisions moving forward on whether or not you need to dredge. Basically, this data is going to allow you to plan and budget for dredging. It's going to be everything you need to get the ball rolling on your project. Another thing is that a sludge survey might uncover hidden issues. For example, we've found really bizarre things in cells. To name a few, I've got some good examples here. Liner bubbles that are subsurface. So if you have an HDPE liner, we've seen the liner detach from the clay base or whatever the base is and form bubbles underneath the surface. And so you're losing a ton of capacity in that case. We've observed broken inlet pipes where normally you'd experience sort of a high concentration of sludge around the inlet. We see sludge building up in other locations where the inlet pipe is and it's broken. We've also seen where an inlet pipe is causing sloughing in certain areas. We've also observed sludge beaches in places we didn't think there would be due to old septage dumps that are no longer in use, or even just from big cattail beaches that have been growing year over year. We've also found submerged lagoons that were inside of the lagoon we were surveying. So we found multiple cells inside of a single cell. And in both cases that I'm thinking of right now that were recent, the operators had no idea that this was the case. And in one of the cases, there was dredging done of an old clay liner. So I could only imagine if I was a dredge contractor, that would be really, really challenging to go ahead and try to dredge a clay liner rather than going after just the sludge. So doing a sludge survey also, it gives you that data so that you can start to rule out other potential issues. For example, like if your cell is full of sludge, you may not have an issue with poor effluent quality that is related to the influent quality. So rather, maybe you just need to desludge and your lagoon goes back to normal. So it can really start to help you understand what the full picture is inside the lagoon. Unfortunately, if you don't have a sludge survey, what we've seen is that dredging quotes, they can really range significantly. So we've seen that without a complete and accurate sludge survey, contractors are finding it really difficult to bid projects. So they're ultimately guessing what they're going to be up against. And so they need to protect themselves by being a little more conservative with their pricing in that case. And so then you start to see a lot of different prices for the same location. And this is where sludge survey data really helps them to bid on the same information. All right, so we're going to talk a little bit here about using sludge survey data. We're going to focus on metrics for a moment here. Sludge surveys are more than just the bright maps that you see here. The important data that we provide, we provide a number of different sludge volumes and also corresponding dry tons. And these are two units of measurement that contractors need in order to understand what they are up against. So when they're dredging, they're moving a certain volume of sludge, but they also need to mix water into that sludge in order to make it pumpable. And so that's why they want to also know the dry tons associated. That's critical to their production. So we're providing total sludge volume, the dry tons of sludge. We can also provide area-specific volumes. So in this example here, what we've done is we've basically highlighted a couple of regions around a couple of intakes that show basically different areas with different volumes, so that if your budget is tight, you can say, well, what can we actually do this year? Can we work around this inlet? Can we expand to this other inlet? Basically, the data is there to give you options. We also provide dredgeable volumes, which basically provide an offset from the liner, the clay liner of the lagoon. And then we provide hydraulic capacity, which we talked about earlier, and then total potential volume, so you know how much volume your lagoon has before you're going to have a flood. It's basically up to the high freeboard mark. Now we're going to talk a little bit about the maps we provide. This specific map here is a sludge blanket distribution map, and we have another one there. But the intent with this map is to illustrate how dredge contractors can use it and how you can use it in your planning process. So what we see here is a couple of cells in a lagoon where sludge has built up in the north end. So if we look at our scale here, blue is basically 0 buildup. Red is, I think it's about 2 meters buildup in this cell. So you can see that most of the sludge is built up in the north end of this lagoon. So the contractors are going to need to focus their efforts here. And that's really important for them to know, because you're going to want them to start here rather than setting up all their equipment to start from the south end. Another thing that we can see here is that we've overlaid where the actual aeration lines are, and we can see the influence of the aeration on the sludge blanket. And in a couple areas, I think this line here, you can see that there's not really any pockets of aeration, which likely means the aeration is either completely buried there or broken off the lateral in that case. And so that can be something that you can address. Okay, and this is another map that demonstrates excessive sludge accumulation. So there's a large beach forming around the inlet in this waste stabilization pond. You can't see it from shore, so you don't really know that it's an issue, but it definitely contributes to significant odor, and it's also causing some short circuiting into cell 2. So the buildup in cell 2 here is only going to get worse if this cell is not dealt with. But now that we have the data, we can see the issue and we can action it and put a plan together. Now, finally, we're going to talk about some supplements here that can help your planning process. We've got 3D sludge maps. Basically, these provide a visualization for you to fly around, zoom in and out of. Essentially, these are great tools to present the needs to dredge to less technical groups, whether it's council or whoever you're going to for budgeting, and then to planning on where to start dredge. And actually, in this example, our client is using these maps and another tool that I'm going to show you in a second here to position their mixers to break up some of the really heavy sludge mounds that are built up in their lagoon. So we have a mobile field app that allows dredge positioning over areas of sludge buildup. This map allows our data to be georeferenced to where you are on site. So essentially, just like your Google Maps or Apple Maps app, when you're out on the lagoon, you see basically a blue dot exactly where you are, so that you know you're in the correct location of where you need to dredge. This is just a free app we provide with our comprehensive surveys. But this is enabling more efficient targeted dredging. But in this case, our client is also using it to reposition his mixers to really break up some of those really thick areas of sludge that you can see here in the red. We also have a virtual site tour that allows stakeholders that maybe are unable to leave their office and visit the lagoon to actually visit the lagoon without the smell, which is kind of nice, depending on the lagoon that you're at. We include a whole bunch of embedded photos, and those embedded photos can show problem areas and notable findings that our field crew actually observes. So when they're out there surveying, they're walking the entire site. They're on the cells, so they're going to see a lot of things that a lot of operators do miss. So we found this to be a pretty helpful tool. Okay, here we go. Let's talk about sludge composition. This is extremely important when it comes to budgeting for dredging. As a baseline, we provide physical properties, so percent total solids, percent volatile solids, and specific gravity. That's so we can calculate dry tons of sludge in each cell, like I mentioned earlier, which is really important for contractors. We can also analyze for other disposal characteristics, such as land application or landfill criteria, each of which basically have their own required tests, and they do differ province to province. And so if you do actually have some other concerns as well, for example, if you have potentially some unauthorized dumping at a site, or if you're operating an industrial wastewater lagoon, you can request us to look for additional basically criteria, and we can just include them in our analysis as we do them. Yeah. Now we're going to quickly talk about dredging versus desludging. These names are often used interchangeably, but I'm going to just provide some clarity so that when you hear folks talking about dredging versus desludging, you can really understand what the differences are. So basically, dredging, you can see this picture here. This is a picture of a floating cutter head suction dredge. Basically, it's got a ladder on it that swings down with the cutter head that goes into the sludge, and the sludge gets slurried and then pumped from there. These are typically used on larger, shallow cells. Their reach is sometimes limited. They're perfect on large wastewater lagoons. They also can be used on cells that can't be dewatered. So if you need to keep your cell in service, the dredge is your choice. And they operate sort of like an underwater vacuum, if you can imagine that. And now we'll look at desludging here. In desludging, cells are mixed and dewatered. And so contractors will use a tractor-powered agitator pump and a lagoon crawler, not necessarily at the same time, but sometimes. And what they do is they create a big slurry, and then they pump everything down in that cell. And this is really good for land applying sludge because they can obtain the correct density of sludge to load trucks and then land apply that sludge. And this is typically used on cells that can be dewatered. So there you go. Now you know the differences. Now I'm going to talk a little bit about disposal considerations. You're going to need to really think about this sort of before your sludge survey and then after your sludge survey. So dewatering is really important. Once the sludge comes out of the lagoon, it's going to need to be dewatered unless you're land applying it. And before I really talk about this slide a little bit more, these parts, dewatering and disposal, are parts of the desludging project that you need to really speak to your contractor about. Your dredging contractors are experts at all of this, at all of the types of dewatering and basically all the types of disposal. And so they're going to be able to put together the correct package for your specific community or your wastewater lagoon. So dewatering, again, based on space and the disposal option you have available for you. Disposal of sludge is a very significant cost for the entire project. Now, I can't stress that enough. It is a huge portion. And so sometimes communities have all the options available. They have farmland nearby. They have a landfill nearby that's willing to accept sludge. And so that they have options there. Other times you may not have a landfill, but you have farmland, or maybe there's nowhere to land apply in your region, and all you have is a landfill. So then you have to look at specifically those options for desludging, for disposal and then dewatering. Another one here the most common options that we see are landfill hauling. So that's when sludge is pumped out of the lagoon by a dredge. It's centrifuged or dewatered in geotubes on site, and then either hauled to landfill right away, or if you can allow the geotubes to dewater for a while, the geotubes will be dug up and that dewatered cake will be hauled to landfill. There's also land applying, and so that's where sludge is pumped into large trucks, and those trucks land apply those biosolids. And then there's also spoil pumping, which is known as gravity thickening. That's kind of the technical term. That's where you basically pump into a large area and allow gravity to do its work and dewater that sludge. Now, contractors can basically provide you with the best option based on the sludge composition and your preferred method, and also based on your budget if you have multiple methods available. So again, talk to your contractor when you're going through this process. Now we're getting towards the end here. Cost considerations, we might go a minute over or so. This is really important. These are the big, important costs that you want to look at and you want to break down. So you need to know if you're going to budget for an entire dredging or a partial dredging. Now, when I say entire dredging, I mean you want to dredge everything that needs to be dredged, all 5 cells that you have, for example. Or you're going to look at partial dredging, maybe only dredging 2 cells out of 5 because that's all the budget you have. Or you want to look at just dredging around an inlet, for example, or around an area of a cell that is particularly bad. We do see that a lot in our surveys where there's a big buildup of sludge in a particular area that needs a lot more attention. And so you may want to focus on that and budget for that depending on how much budget you have available. So you're going to want to consider, like I mentioned, the cells dredged, and then of course the volume and dry tons you need to remove. You're going to need to consider whether dredging or desludging is your option. Again, you'll be speaking to your contractors about that. What dewatering method are you going to use? Do you have the space for a spoil or geotubes? Do you have no space and you need to use a centrifuge? Do you have to do any civil works for site prep? If you've never dredged before and you have a laydown area for geotubes, there's some site prep that you would need to do. Perhaps you need a laydown area for the contractor because your site is very small. So keep that in mind, that that's going to be another cost consideration. And then your disposal choice. Do you have that landfill nearby? Can you land apply? Or are you going to just leave things to dewater in a spoil? And then finally, what is your cost benefit analysis here? So you may want to undertake that. And I definitely recommend involving a professional wastewater consultant. So that might be an engineering consultant to look at this, because when these projects start to get larger, they do take a lot of time. There are a lot of working parts. It's manageable, but it can be helpful to involve a professional wastewater consultant at this point. And then so finally, before I let you go here, we are going to talk about the decision-making process. And so let's just run through this decision tree. So first we start with signs of overaccumulation, because if you don't know that your lagoon needs to be dredged, well, you don't know it needs to be dredged. Maybe you don't go out there, maybe things are looking okay. But let's say you do have some signs of overaccumulation. Maybe there's a beach happening, maybe you're struggling with effluent criteria. Well, your first step is going to be to conduct a sludge survey. And then from there, we have a bit of a rule of thumb. If you have significant sludge buildup, that's greater than 30% in one or more cells. You've got a yes or no here. So let's just say, for example, you have less than 30%, but you've got a notable area of concern. So say you've got a lot of sludge built up around an inlet. From here, you're going to go into your planning stages for dredging and desludging. And this is where you ultimately may want to bring in a wastewater consultant, a wastewater professional. And then from here, you're going to assess your disposal options and your site constraints. And You're going to inject and use your sludge survey data, and also your contractors are going to use your sludge survey data to obtain budgetary pricing, or to give you budgetary pricing, excuse me. And then finally, we've got our project quality management system. Do you have it in place? If you don't, you're going to want to build a QM plan, so that it might include interim and final surveys, spoil and pile measurements, and then discharge sampling. So once you've done that, award the project, follow your quality management plan, and complete your dredging. Obviously, the process is a little bit more complicated than this, but generally you can follow this for decision making, so that you can start to make your way through, and so that you can start to tackle this seemingly really large and difficult project. All right, so that's it for me. Just a few key takeaways here on my last slide. Don't let minor issues get worse. We've seen it happen. Periodic inspections and regular maintenance do go a long way. Monitor that sludge blanket periodically. Start with a baseline sludge survey, figure out what's going on. You may not have to do anything, and that's great. Beyond 3 years, we start to see that sludge data does need to be updated. Things change in your lagoon. So consider, if it's been 3 years or a little bit more, you may want to have your sludge blanket data updated. You do have options: dredging versus desludging, different disposal options, but consider all the possible costs so that you can get the best budget. Then finally, complete your project. Use the tools that are available, get a solid plan going with a budget that suits you, some contingency built in there, and then ultimately remember quality management when you go through this project to ensure that your project gets completed properly. Okay, well, I went over a few minutes there. Thank you again, everybody. I do really appreciate your attendance. And if you do have any questions, I'm going to just check out the chat here. So I don't see any specific questions in the chat. I'm just going to look at another area here. Oh, I've got one question. A question that I have. I'm not going to say who sent it in. The question I have is roughly, what does it cost to have a sludge survey done, and what does it cost to dredge? A sludge survey is it's a much smaller cost than dredging and desludging. So with a sludge survey, you are looking at in a range of sort of $2,500 and upwards per cell, usually up to the $4,000 or $5,000 on average per cell. It really depends on your location, the size of your cells, how many cells you're looking to have done at once. So it does range, but if you specifically want to know, we can provide you with a project proposal. And then cost to dredge, that is really dependent on how much sludge you have, how many cells you want to have dredged, and that can be very expensive. We've seen smaller dredging projects, $100,000, $150,000, upwards of several $1 million for multiple cells, over the course of several years. So big different scopes there, but really I want to stress the importance about staying ahead of this stuff, getting all your information together, and putting together that plan, because it won't be so bad when you need to do this stuff. So I don't have any other questions at the moment, but if anybody does have any questions, just feel free to reach out. I think everybody has my contact information. So like I said, reach out with any questions that you have. I did just get a quick question here. So they're asking, what is the best way to check for quantities for payment of the desludging contractor? So again, if you do have a pre-survey completed, what you can do is you can do a post-survey and compare. You can compare what's been removed from the cell. But if you do have that material that is somewhere, it can be measured and sampled for volume and dry tonnage calculations. That's a really good way of doing it. Also coupled with that post-survey to compare what's been removed from the cell. those two items can closely correlate quantities for payment. If you are setting out to set up a big contract for desludging, I definitely recommend considering both payment based on volume and payment based on dry tonnage. But you'll want to make sure the contractor has a way to measure both of those, or that you're putting that quality management plan in place. But feel free to reach out. We can talk a little bit more detail about setting up a proper quality management plan for the project, if it's not already been started. So that's all I see so far for questions. So I'll end it here, let everyone get on with their day. Thank you very much for everyone that attended. I do really appreciate it. And likewise, thank you guys. And if anybody has any questions moving forward, please feel free to reach out. But with that, I'll end it here. All right, take care, everybody, and have a great day. And yeah, we'll talk soon. Bye for now.